Hey guys, we're back for round two. Get excited. Now, this one's a little different from the last one, so I will make you watch example two. I'm sure after I set it up, though, you'll be able to figure it out, but let's see what happens. Okay, so again, we're going to use the same information from the top, which says UP, TP, and PS are angle bisectors, which this is the same picture as this one. I know they don't look anything alike, but it's okay because I did not say my picture was drawn to scale. So I can use the same picture and it could look completely different since I did not say that. So just saying. But anyway, so I know that these three are angle bisectors, which means they slice the angles in half. So I'm going to label that just in case it will help me when I'm solving. It might not, but let's see. So this angle is congruent to that angle. This angle is congruent to that angle. And this angle is congruent to that angle. Yay! All right, let's see what this problem has in store for us. So it says S to the B is 6, which I'll label my picture as I go. So SB is 6, PS is 10. So PS is right here. And then it says, what is PD? So they want to know what this is. This is the one I'm finding. Okay, this is the one where I don't know yet. I'm going to put a question mark. Even though that doesn't really look like a question mark, that's a question mark. Okay, so that's the one I'm trying to find. Okay, which, again, I was given segment links, so unfortunately this angle business is not going to help me. So, oh well, we labeled it just in case, just to be sure, but it's not going to help me. Okay, so currently I know that this length is 10, and I know this is 6. Okay, which if we go back to that lovely angle bisector incenter theorem, remember the incenter, which is the point where all three of my angle bisectors intersect. So if we look at this picture, this bad boy right here, P is my incenter right here. This is my incenter. Because that is where all my angle bisectors come together. But anyways, so our angle bisector incenter theorem states that if you draw perpendicular segments to the side of a triangle from the incenter, they're congruent. So I'm going to mark that again. So these three bad boys are congruent. Bam, bam, bam. Oh, you didn't see that. Sorry, guys. I just marked that these three are congruent. I thought you could read my mind. I thought you were a mathematician, which you kind of are, but these three are congruent. Okay, so in the last problem we did, we were given those segments, which helped us to find the missing one. This time we're not, though, so we kind of have to go further into the picture to find another way to get PD, because I don't know PD. Okay, I was given these two segments, which seem kind of random. Do you see a shape using these two sides that might help me to solve? Which, don't forget, you guys, if this is a right angle, what is this angle right beside it? It would also be 90. You guys are so smart. So these two are 90 because they form a linear pair right here. This is a line, and these two angles are side by side in a line. And the angles of a line add up to be 180. So like these two are 90 degrees, and these two are also 90 degrees. So do you see a shape that might help me to solve what maybe one of my perpendicular segments are? Because if I know one of them, then I'm going to know all three of them. So do you see anything? Look deep into the picture. Let's look up and close at it. Get close and personal. Do you guys see anything using these two segments that might help me solve for one of my perpendicular segments? Holy hot dog, you guys are so smart. I don't even know why I do these videos for you guys, because you guys already know everything. But anyways, there is a right triangle, which actually I'm going to zoom back in. Sorry, guys. So do you guys see this right triangle right here? I'm going to try to shade it. This right here is a right triangle. And how do we find the sides of a right triangle? Holy hot dog, we do use Pythagorean theorem. Okay, guys, so that right triangle will help me to find one of my perpendicular sides, which then I will know what all three of my perpendicular sides are. Cool beans, right? I know. Okay, so let's see. So I'm going to redraw that triangle over here so we can only focus on that triangle. Okay, so I'm going to draw a sketch of that triangle, which I'm going to draw like face up like this so it doesn't look all weird and sideways and crooked and hard to read. It's much better if the triangle's upright when we're solving. So I'm going to draw it like this because that will look closer to it. Okay, which I'm going to label the lengths of the sides. So we have S. S is going to be here. And then we have B, which is here. And then we have P, which is here. Okay, so let's relabel our side lengths. So it says that S to the BSB is 6. And then PS, so this side is 10. All right, what is the Pythagorean theorem? You guys are so smart. It is a squared plus b squared equals c squared, which the a and the b are the sides of my right triangle. What is one side of the right triangle? Sorry, the a and the b are the sides that form the right angle in the right triangle. Sorry, guys. So what are two of my sides that form the right angle? Yes, they are. So SB is one of the sides and PB is the other. So I'm going to label this. It doesn't matter if you label one A or one B. You can do this one A or this one A. Doesn't matter. All right, and what is this side across from my 90-degree angle called? It is the hypotenuse. So remember that joke from back in the day, the hippopotamus. That was a board slapper. All right, but anyway, so that's a 10. All right, and that's my hypotenuse, which is going to be my C. Alright, well let's substitute in these values into the formula and find the B value, which B is PB over here, which is one of my perpendicular lines that's drawn through the triangle, which if I know PB, then I'll know PD. So that's exciting, which I'm actually going to write that off to the side. I know that PB will equal PD when I get done, which is what I'm ultimately trying to find. So let's keep that in mind. Okay, let's set this bad boy up. Alright, so my A is 6, so I'm going to write 6 squared, plus B, which I don't know, which is side P to the B, so I'm going to write PB squared, equals C squared, which my C is 10, so 10 squared. Alright, let's solve this thing. So 6 squared is 36. Plus PB squared, which I don't know yet. So plus PB squared equals 10 squared. 10 times 10 gives me 100. All right, let's solve this thing for PB. Okay, so I need to get PB by itself. So how do I move 36 to the other side? Yes, I would subtract it on both sides. You guys already know how to do this problem. Alright, so 36 minus 36 cancels out and turns to 0. 100 minus 36 will give me 64. So right now, I have PB squared equals 64. Okay, which I'm going to write that over here. So PB, quantity squared, equals 64. Alright, let's solve this thing for PB. So how do I undo a squared? I would square root it, and I'm going to square root that thing on both sides. Bam and bam. Okay, which the square root will cancel out my squares since they're inverses of each other, which means the PB can be just dropped down. And then what is the square root of 64? Holy hot dog, it is 8, you guys. Which technically, you guys, when you square root both sides of an equation, what should pop up? A plus or minus should pop up, but does negative 8 make sense for the length of a side of a triangle? No, you cannot have negative 8. Okay, so when I write my answer, I'm just going to write the positive 8, which is the one that makes sense. All right, guys, so awesome job, awesome job. We found PB, which that's going to be helpful over here. So we know PB equals PD, so PB equals 8. What does PD equal, you guys? Yes, it does. PD equals 8 as well. And that is what we're ultimately trying to find. Oh man, wasn't that epic? It was super epic. I'm glad you guys enjoyed it as much as I did.